All right, on 37, what you're going to do is you are going to set the numerator equal to 0. So you have negative 4x squared plus 1 equals 0. Bring the 1 over and divide by negative 4. So what you're going to do is solve for this. You end up getting plus or minus 1/2. So everyone should be able to set this equal to 0 and solve. You get plus or minus 1/2. Is everyone okay with that? Mm-hmm. And also in the denominator you have 0. Now what you could do is you could do these separately. What I did was I used negative 4x squared plus 1 as one factor up here. It's okay, you can do that. And then I did x and x separately. So negative 1/2, 0, and 1/2 are my critical values. Now for this one, this is tricky. If you were to graph this y equals negative 4x squared plus 1, think about it, what this thing looks like. This is what it looks like. This would be negative 1/2, and this would be 1/2. So from negative infinity to negative 1/2, all of the numbers are negative. From negative 1/2 to 1/2, they're all positive. And from 1/2 to infinity, they're negative. So that's how I got my negative, positive, positive, negative for that one. What you could do is just plug a number in and test it. So does everyone understand this? The negative, positive, positive, negative. And then for x, the 0 would be 0, so to the left are negative, to the right are positive, and same with this one. So when you count, you have 3 negatives, so negative, 2 positive, no negative, so positive, and 1 negative. It's going to be negative, positive, positive, negative for that one. For this one, the degrees are both the same, so it's going to be y equals negative 4. Because if the degrees are the same, you take the leading coefficient of the numerator over the leading coefficient of the denominator. There's no y-intercept and there's no hole for that one. So what does your graph look like? You have 2 roots at negative 1/2 and 1/2. So here are your roots, and your y equals negative 4 is your horizontal asymptote. So from negative infinity to negative 1/2, it's negative. According to this, it's negative in the negative. And then from negative 1/2 to 0, it's positive. We have 2 asymptotes, one right here, vertical at x equals 0, and y equals negative 4. And then from 0 to 1/2, it's positive, and from 1/2 to infinity, it's negative. So that looks like a Christmas tree. Good?
It doesn't look like a Christmas tree.
Okay, number 39, I think is tricky. I'll tell you why. When you do this one, you factor out an x, and the bottom you're going to factor x minus 5x plus 1. Tell me if I'm going too fast for you guys. Your critical values are 0, negative 2, 5, and negative 1. And I put them in numeric order right here. 0, negative 2, 5, and negative 1. My factors are here. And I counted and I did all my, you should get a positive, negative, positive, negative, positive. This is where this one's tricky. The degree of these two are the same, so it's the leading coefficient of the numerator over the leading coefficient of the denominator. So y equals 1 is your horizontal asymptote, and vertical asymptotes are at x is equal to 5 and negative 1. And 0, negative 2 are your roots. So when you do this one, you're going to see that your graph is going to cross at the horizontal asymptote right here. It has to. And that's where you have to keep in mind, horizontal asymptotes are weak asymptotes. Okay? They're weak. They can cross. Horizontal asymptotes are more for end behaviors. They get closer. They migrate towards the ends of these asymptotes, the end behaviors, out to the extremes. Positive and negative infinity. Anybody have any questions on that one? Okay, moving on. We now have a hole. Your first hole. Ready? So for 41, when you do this one, Colin, can you see this in the camera?
Yeah.
Okay, good. So whether it's factored or not, you may have to factor it. I have this one factored for you. These two x plus 3's are factored out. And because they're factored out and you lost something important in the denominator, what did you lose? You lost x equals -3. There's your whole. It's at -3 something. Does everybody understand why you have a hole? Because you lost this. This would have been a vertical asymptote. So your problem now reads x minus 3 over x minus 5, x plus 4. So what you need to do, you're going to do this problem. This is your new problem that you have to do. You no longer have to do this one. Do this one. It's simpler. It's cleaner. Less to work with. So we have a hole where at -3 what? What do you do to find the y value?
Plug in the hole.
You're going to stick this -3 right here. So you have -3 minus 3 over -3 minus 5 and -3 plus 4. Can you evaluate that for me? I heard it 3/4. This reduces to 3/4. So on your line, you're going to put -3, 3/4. Okay, so we got that straight. That we canceled those out. We have a hole. Where are your roots? We have a root at 3. So when we graph this, here's my. I didn't draw give you any graph paper for this, but you can just sketch the graph. At 3 on the x-axis, you have a dot. We have two vertical asymptotes at 5 and at -4. This is bottom heavy. Y equals 0 is your very common asymptote, horizontal. There is no parabolic, and notice how all along I've been putting x's. If there's something not necessary, I put an x. Don't leave it blank, put an x. What's the y-intercept? What does y-intercept mean? You put a 0 for x. If you put a 0 for x, you may be able to do this in your head. You get -3 over -20, so 3/20. So at 0, 3/20. Just put a dot somewhere in between 0 and 1. And now let's do our exclusion chart. Do I need to deal with this whole mess here? No. Only the stuff here. So 3, 5, and -4. So x minus 3, x minus 5, x plus 4, and f of x. So quickly, at right here, at 3, these would be negative, these would be positive. And at 5, these would be negative, this is going to be positive. At -4, negative, positive, positive, positive. So we count, we have negative, we have positive, negative, positive. So help me out, how am I going to draw this graph? Put it together. From -4 to the left, it should be in the negative, so we've got that there. Now we want to be in the positive region. Our next region's in the positive, so it's looking like this. And then we're going to pick up this. We're still in the positive. And now from 3 to 5, we're in the negative. So we come down like that, and then we're in the positive. Now we have one little problem we didn't do. We need to put our hole in. So our hole is at -3, 3/4. So my graph is a little too high right here. So I want to make sure, and obviously if you had a piece of graph paper, it would look nicer, and a nice eraser, that would work. Oh. Anyways, here's a better picture. That's what it should look like. Bigger drawn to scale picture. There's your hole at -3,3. You want to put a hole there. Because this normally, guys, this would be an asymptote at -3.
Yeah.
Questions? Let's try 43. We have 3 more. How do you factor 43? X plus 3.
6 minus 3.
Oh. Well, it looks like we're not going to have a hole, right? So what are your critical values then? And you want to make sure when you do these critical values, you put them numerically in the correct order. So I will write x minus 3, x plus 2, and x minus 2, and then f of x. So are you guys okay with doing this exclusion chart? You know how to do it, okay? So you put here's your 0 for x minus 3. These will be negatives, this will be positive. X plus 2, so at -2, there's your 0. So that's going to be a negative, these ones will be positive. And at 2, here's your 0. There's another thing I want to tell you guys, where you're going to get yourself confused. Negative, positive, negative, positive. I see how I put my critical values right there. I see students do this. They'll make their chart and they'll put their critical values like this. I wouldn't do that. Do you see the problem? I see this happening, and then they don't know what to do. They get themselves confused. Think of a number line, and you're putting the number -2, 2, and 3. So you're evaluating the stuff in between, here, in here, in here, because something's happening to your graph. I hope that makes sense. So, okay, what are your roots? 3 and -2. So let's start constructing this graph at 3, 1, 2, 3, and at -2. Vertical asymptotes are x equals 2. Ooh, this one's top heavy by 1. What does that mean? Top heavy by 1.
Slowly.
How do you find it? Can I do synthetic? Why?
Because it's x minus 2, so it's just 2.
Now, I can stop right there. Notice how I didn't finish it? Why? Because this is your remainder and we don't need it. But if you want to, you could. Your remainder is -4, you don't need it. So did everybody understand? You're bringing down the 1. Where did I get the 1 from here and the -1 from here? So where did I get the 2 from here? It's the opposite of that number. You bring down your 1, 2 times 1 is 2, and you add. These numbers are important. So what is that? Y equals 1x plus 1 is your slant asymptote. Well, where is y equals 1x plus 1? It's right here. So it looks like that. There's your slant asymptote. And the y-intercept is 0 what? 3. If you put a 0 here, here, and here, you get -6 over -2, which is 3. And there is no hole. So 0, let's make that 0, 3 right there. All right, where's my graph? From negative up to -2, it says we're in the negative region. And from -2 to 2, we're in the positive. So it's going to look like this. I'm going to use it yellow or pink. Let's use pink. from here to here, it's gonna be in negative, right there, negative, and then positive. Pick that up, positive, carry that up. Then from 2 to 3, it says we're in the negative, and then we're in the positive. Questions? Two more and we're done. 45. How do you factor 4x squared plus 4x minus 3? 2x minus 1, 2x plus 3. Let's check it out. That's 6x minus 2x is 4x. So I need all of my critical values. This is going to be 1/2, and then negative 3/2, and 5/2. So if you were to order them on a number line, I'm going to put them in decimal form, okay? And then, is everyone okay with that? I'm making my exclusion chart here because I'm writing bigger. So now we have our 2x minus 1. Yeah, let me do it here. 2x minus 1. And then we have 2x plus 3. And then we have 2x minus 5. And then we have f of x. Okay, so these are not that hard. Set that equal to 0. So it's 1/2, right? Which is right here. So these are going to be negatives, and these are going to be positive. And then negative 1.5, right? Which is right here. That's the negative one, and these are the positives. And this is your 0 right here, so these are negatives, and that's positive. So we count, we have negative, positive, negative, positive. So let's finish this. We have roots at 0.5 and negative 1.5. This one you're going to want, I'm going to show you a nice graph of it. Your vertical asymptotes are x equals 5/2, which is 2.5. And this one is top heavy. It's top heavy by 1 degree, which means there is a slant asymptote. But unlike the last question, we have to do long division to do it. You're going to have to do 2x minus 5. This is not an exclusion chart in here. You have to do long division. You have to do 4x squared plus 4x minus 3. You're going to get, when you divide this, you get 2x plus 7. How do you get that? You want to get rid of this. 2x goes into 4x squared 2x times. You get 4x squared minus 10x. Subtract, you get 14x, and then plus 7, because 7 times 2x is 14x, and you don't need the remainder. So this is your slant asymptote. It's y equals 2x plus 7. So when you graph this, you need to make sure you want a piece of graph paper so you can see it. So how do you graph y equals 2x plus 7? Where are you going to begin when you graph? How do you graph y equals 2x plus 7? Begin at 7. And you're going to go down 2 and over 1. This is your slant asymptote. So this slant asymptote I have on a piece of graph paper. like that. So is everyone okay with the slant asymptote? Now your y-intercept, we didn't finish this, y-intercept is 0, 3/5, which is about right there. Let's put our roots, 0.5 and negative 1.5, those are our roots. And we also had a vertical asymptote of 2.5, which, here it is. So far that's what we have. Now let's put our information from our exclusion chart in here. It says from negative infinity to negative 1.5, we're in the negative region, okay? So this is where you're going to be. Here is in the negative region from negative infinity to negative 1.5. Then from negative 1.5 to 0.5, you're in the positive region. We're going to pick up our y-intercept, and then we're in the negative region. And then the last says we're positive. So the positive one, the only way you're going to draw this one is way up here. You're going to draw this little, looks like an archy. So because you have two asymptotes right here. So to be contained in the positive region within these two asymptotes, you want to be way up there. So this is this graph. That's the only way you'd be able to not cross those asymptotes and stay in the positive region. Any questions? We have one more and we're done. Number 47. How are you going to do this one?
No, it's just messy.
You're not Trevor's.
No.
We're done.
Yes.
What?
We're done. You don't have to do that last one.
Screw you.
Thank you, Jesus.